we defined float earlier as the spare time available on non-critical activities. Do you remember when we talked about some redundant time someone might have? That's the float. That this is the spare time available on the non-critical activities. And in here we split it into three, where one is called the total float. Then the other is called the free float, and the other is called the independent float. Okay? And they're defining what total float is, and they are even giving us a formula there of how total float is computed. They're telling us that total float is the amount of time a path of activities could be delayed. You see, we've had so many paths. Are you together? So many paths, isn't it? But now they're telling us that the amount of time, let's say we are looking at this path. This path could be delayed without affecting the overall project duration. Are you together? You could delay this, but at the end of the day, it doesn't affect how long the project is going to take. Are you together? That is total float. And the next is free float. They're telling us that this is the amount of time an activity. Now you realize we've moved from this is the amount of time an activity can be delayed again without affecting the commencement of the next EST. Of the next activity. You don't want to affect the next activity. Okay? And what is happening is, even if you delay this particular activity, it's not actually affecting this, it's not becoming a problem with this. Are you together? That's what free float is. And the next is going to be independent float. And we are saying that this is the amount of time an activity can be delayed when all preceding activities are completed as late as possible, and all succeeding activities completed as soon as possible. Let us read this again. They're telling us that this is the amount of time an activity C can be delayed when all the preceding, whatever is coming before it, are you together? Whatever is coming before it, are completed as late as possible. Are you together? What you're doing is, you're delaying A, are you together? But in you delaying A, for A to start at any time, okay, this A is finished in the latest possible time. Are you together? If A is finished in the latest possible time, this C, activity C, is the one that we are focusing on. It's the one where we're saying that the amount of time of this activity, when all the preceding activity, this one, is completed as late as you want. Are you together? But what is happening in front also is able to be finished as early as possible. You're delaying this, are you together? But when you delay this one already doesn't care. However much you delay to start. For me, whatever is going before me, after January, is going to be finished in time. Are you getting that? Some of them might be a little confusing, but I know we shall get them as we go with the example. Let's go. In fact, I'm going to skip this example here, and we shall go to something called cost analysis. Let's go.
I would like to understand something. When you look at our events 1 and 2, so what I would like to understand is, does it mean that in reality, event 1 is activity A, so that the stretch between event 1 and 2 is the time duration.
I don't want to say that. This is an event you put for you to start. If you build a project, you will see them doing what they're calling commissioning. It's starting. You see the ministers cutting those things. You see them in the tractors. The project is kick-starting. Okay? Ideally, the project has not started in the real sense, but it's an event that is happening. You get it? After that event has happened, then for you to get to do, for you to say that I've finished bush cleared on the road, I've finished bush cleared, that means you cleared. You did the clearing. So it's as though the deliverable of the activity. I take it. What comes from the activity is the event. When you do something, what it leads to. You get it?